Hello, in this video we will do exercise 17, page 15. Find the GCD of each pairs of numbers in each of the following cases. We have 17 and 34. We have to find the GCD between them. First, we think they are consecutive. No. Is there a relation between them? It means the smallest number times something equals the biggest number. 17 times a number equals to 34. Yes, it is 17 times 2 equals to 34. So we have a relation between them. In this case, 17 is a divisor of 34. 17 is a divisor of 34. So, GCD of 17 and 34 is equal to 17 is equal to the small number because it is the divisor. So we think they are consecutive? No. Is there a relation between them? Yes. So 17 times 2 is equal to 34. So 17 is the divisor of 34. So GCD is equal to 17. Now we have 42 and 43. They are consecutive. We think they are consecutive. Yes, they are consecutive because 42 and 43, they are, one of them is next to the other. So 42 and 43 are consecutive. So what is the GCD? So GCD is equal to 1, and in this case we say that they are relatively prime. Now 16 and 48, we think they are consecutive? No. 16 and 48 are not consecutive. Is there a relation between them? We think 16 times a number equal to 48. Yes, it is 16 times 3 equals to 48. In this case, 16 is the divisor of 48. Is a divisor of 48, and the GCD will be what? Will be this divisor, the divisor. So GCD of 16 and 48 is equal to 16. Now part B. Among the following pairs of natural numbers, indicate those formed by relatively prime numbers. So here we have to see if the numbers are consecutive or the GCD is equal to 1, or we can think if they are a common divisor. If we see directly they have a common divisor, so we say directly they are not relatively prime, because relatively prime means GCD is equal to 1, and it means that they have no common divisors other than 1. So here 9 and 16, can we see directly they don't have a common divisor? We can find the GCD directly because we know that 9 is equal to 3 to the power 2. Without the tree method and without finding anything, we know it. And we know that 16 is equal to 4 to the power, 2 to the power 4. We do it the last time. So the GCD of 9 and 16 is equal to 1. GCD equals to 1, and they have no common divisor. So GCD, no common divisors other than 1. So GCD of 9 and 16 is equal to 1. So in this case, they are relatively prime. So 16 and 9 are relatively prime. Now look at 21 and 25. We know that 21 is equal to 7 times 3. We can know it directly. If we don't know, they are small numbers, so they are easy. We can do the tree method. And 25 is equal to 5 to the power 2. خلاص, we know it. So now the GCD of 21 and 25 is equal to what? Look, we have no common factors, so it is equal to 1. So 21 and 25 are relatively prime. Now we have 30 and 48. They are consecutive? No, they are not consecutive. So we have to find the GCD. Here we don't know. 30, yes, we know 30 is equal 5 times 6, but we have to decompose also the 6, and we have to do tree method, and we have 48 is a big number, and we have to decompose it, and we do tree method, and we find GCD. But don't you notice anything? We have here 0 in the ones digit, and we have here 8 in the ones digit. So these two numbers can be divisible by 2. So they have a common divisor other than 1. It is 2. So directly they are not relatively prime. So we say that 30 and 48 have 2 as common divisor. They have a common divisor other than 1, so they are not relatively prime as common divisor, so they are not relatively prime. Now we have 48 and 51. They are also big numbers, and we have to do tree method, and they are not consecutive. Is there a relation between them? We don't know. So here, do you notice anything? One's digit is 8 here and 1 here, but pay attention. If we add 4 with 8, we get 12. So this number is divisible by 3. If we add 5 with 1, we get 6. So this number also divisible by 3. the sum of digits is a multiple of 3. So we say that 48. So they have a common divisor other than 1, so they are not relatively prime. 48 and 51 have 3 as a common divisor, so they are not relatively prime. Now, part C, correct the mistake in each of the following cases. The GCD of 16 and 32 is equal to 32? Sure not. Look, we have a relation between them. 16 times 2 is equal to 36. But the GCD will be the 36. The big number? No, it will be the small number. It will be 16. So GCD of 16 and 36 is equal to 16. Now GCD of 16 and 24 is equal to 24. They say correct the mistakes. We are sure that we have a mistake. But the GCD of 16 and 24 is equal to 4? No, they have a divisor bigger than 4. So here, what is the divisor that is bigger than 4? We have here 8 as divisor and 8 as divisor. So the GCD is not 4. They have a bigger than 4. But we can correct the mistake as GCD between 16 and 4 is equal to 4. Why? Because 4 times 4, because to not do the 3 methods and find the GCD, we can correct it like this. We know that 4 times 4 is equal to 16. So 4 is the divisor of 16, and in this case, the GCD will be 4. So we can write 4 instead of 24. So the GCD of 16 and 4 is equal to 4, not the GCD of 16 and 24. They have a common divisor bigger than 4. Now, the GCD of 27 and 33 is equal to 1. They are not consecutive and they have 3 as common divisor. They are not relatively prime. So how we correct the mistake? We can't find the GCD here because we have to do the 3 method and we find what is the GCD, but we are sure that is not 1. They have 3 as common divisor. So here we can correct the mistake. We can take 2 consecutive numbers to get a GCD 1. We can write that GCD of 27 and 28 is equal to 1. Thank you.